In this video, I will be going over lesson 17, which is about ratios and proportions. Our first question says that Faye is following a recipe to make dough. The amount of water in ounces she uses depends on the amount of flour she uses in cups. The amount of each ingredient are shown in the graph below. What is the unit rate of the ounces of water per cup of flour for this situation? Remember that for unit rates, we need to have a 1 in the denominator. And remember, our setup for writing rates is y over x. So when I look at my graph here, my x values are going to be on the bottom, and my y values are going to be going up and down. So if I'm looking to have a 1 in the denominator, I'm looking where 1 is x, and I'm going to follow this up till I touch my graph, which is right here, and follow this point back, which tells me 3. So that means that my y value is 3 and my x value is 1, which means that the unit rate for this graph is going to be 3 over 1, or 3. Our next question says that on a trip to Spain, Kiana wants to exchange some of their money for US dollars to euros. She uses the graph to determine the exchange rate. At which point on the graph represents the unit rate for the exchange dollars to euros? So notice I'm not asking what is the unit rate. I just want to know which one of these points tell me where that unit rate is. And remember, when I write in the form y over x, I need to have a 1 in the denominator, so I'm looking for wherever my x values on this bottom x-axis here are 1. And here is my 1, so I'm going to follow this line straight up, and I get to b, which means that b is the point on the graph that represents the unit rate. Our next question says Dimitri works for a mail delivery service and he tracks the number of packages he delivers over time on this graph. What is the unit rate for the package deliveries per hour? Again, guys, unit rate. Hopefully you're starting to see a pattern here. I have y over x. In order to have a unit rate, I need to have a 1 in the denominator. So I'm looking for wherever x is 1. Once I find that, I'm going to take that grid line and I'm going to follow it all the way up until I reach a point, which is up here, and then I'm going to follow this all the way back until I reach my y-axis, and that tells me it is 8. So here my y is 8, x is 1, which means my unit rate is going to be 8. Next question says a bus driver collects fares as passengers board the bus. He records the fare in dollars and numbers of passengers boarded after each stop. He records the represented in the graph. Which equation best describes the relationship between T and the number of fare collected and P, the number of passengers who have boarded the bus? Anytime you are asked to write an equation or identify an equation, you are looking for something in the form that looks like this, where I have y equals some number and I'm multiplying it by a variable, which means that this one here, where I have this 2 plus p, is not correct because it doesn't follow this format. And t times p equals 5. This one is also not correct because, again, it doesn't follow this format. Now the number that goes in your equation is your unit rate. So whatever your unit rate is, that is the equation you want to pick. In order to figure out our unit rate here, we have to do a little bit of math because we don't have any 1s on our x-axis to tell us right away. So let's use this point here. My x value is going to be 5, my y value is going to be 10, right? 5 and 10. When I write this in the form y over x, I get 10 over 5, and this simplifies to 2 over 1. If I divide 10 divided by 5, I get 2, which means that since my unit rate is 2, I want to pick this graph here that has that 2 next to my variable. Next question. A reporter records points scored in a basketball game through the first, second, and third quarter as shown in the graph. Part A is asking which equation describes the relationship between Q, games per quarter, and P, points scored. Again, remember, we're looking for our variable to be attached to our unit rate. And then B wants to know what score is the reporter predicted in the end of the fourth quarter. So here, if I look at my graph, I have X over here. So my unit rate, it's going to tell, this graph will tell me. And when I follow my 1 and for my X up to my point and then back to my Y-axis over here, I get 20. So this means that my unit rate is going to be 20. So our next step is to look and see, well, remember how I wrote that equation y equals some number times x? X represents quarters. Okay, so I'm going to replace x with a q. And if I look over here, my y-axis represents points. So I'm going to replace y with a p. And my unit rate is 20, so I'm going to replace this dollar sign with that 20. So now I have P equals 20Q, which would be this equation right here. For B, using our equation, we want to know what can the reporter predict to be the end of the fourth quarter points. Well, it looks like they're scoring 40 points every quarter, right? Quarter 1, they score 20. Quarter 2, they score 40, which is an increase of 20. Quarter 3, they score 60, which is another increase in 20. So if they're at 60 and they're increasing by 20, that means that in the fourth quarter, they are going to score 80 points. That is what the reporter can predict. Our next question says a botanist uses a graph to compare total rainfall in inches to plant growth in inches over a 6-month period. Which equation describes the relationship? And B is asking what is the likely total rainfall when the plant reaches 2 inches in growth. So again, here we're looking for something in the form of y equals our number times x. Remember that your number is going to be your unit rate. So let's use this point here. If you notice, my line of this graph intersects directly in this intersection point right here on this graph. So I'm going to use that point because I'll be able to tell exactly what my x and my y values are. So here I have, oops, let me erase that because it's not what I want. So here I have the point 10 comma 1/3. So when I write this in the form of y over x, I'm going to have 1/3 over 10. Okay, and I need a unit rate, which means I need to have a 1 in the denominator, so I'm going to divide both top and bottom by 10. And you can absolutely pull open your calculator to help you with this. I would recommend it just so that you're not spending forever dividing these two numbers. So I'm going to pull over my Desmos, and I'm going to do that 1 over 3, and I'm going to divide that by 10. And when I look here, that gives me 1 over 30. Okay, so that means that my unit rate is going to be 1 over 30. And I realized that when I was writing these equations, I miswrote them. I forgot to change them into fractions. So this should actually say g equals 1 over 30 r. This should say g equals 1/3 r. Okay, so not those two. I apologize. However, I know that my unit rate is going to be 1 over 30, and when I look at all of my equations, this is the only one that has 1 over 30, right? Remember, your equation has to have your unit rate in it. So that means that this equation here is going to be correct. So if I want to know how likely or how many total inches of rainfall will happen when the plant reaches 2 inches, okay? So 2 inches is my growth. I want to know how much rain I need for it to get up here. So when I'm using that equation, let me grab a different color. G equals 1 over 30r. G represents my growth, and I want to know 2. I know 2, so I'm going to replace this G with 2. 1 over 30, and I have r. So now I kind of need to think, well, what number times 1 over 30 is 2? And if you think 30 over 30, if I have 30 over 30, that's going to simplify to 1, right? So if I wanted to get to 2, I could try 60. If I were to double it and have 60 over 30, that would simplify to 2, right? 60 divided by 30 gives me 2, which means that R is 60. So I need around 60 inches of rain for this plant to grow 2 inches. And that is the last problem for this video. Thank you so much for watching. Let me know if you have any questions.